Hello everyone, I hope you all are doing well. Welcome back to my YouTube channel, this side Priya Bhatia. And in this specific video, we will be discussing with respect to the continuation of our ML playlist on my YouTube channel. Till so far, I think I have covered up so many algorithms with respect to machine learning in the playlist. We started our discussion with linear regression, then we went ahead and talked about logistic regression. We talked about decision trees, random forest, right? In this specific video, I'm attaching a clip of recordings of my ML paid bootcamp, so that if anyone won't be able to purchase that specific course, uh, you have a chance to get the access of this free recordings. The only difference is definitely in those paid resources, you will observe that people are directly connecting with me, they're asking me the questions, but here you will just get the recording, but the content is same only. So please enjoy the content, but by saying that, it really took a lot of effort, time, resources. So please make sure that you will also bit your karma by subscribing to this channel, sharing this video with everyone. Comment down below in the video. I have seen that the comments are not coming up nowadays. If you will just write thanks for giving this video, that is the fee for me. So please make sure, if you don't know what to write in the comment, just write thank you itself. That is enough for me, right? I'm really grateful for all the support that you guys are showering on me, for all the love. And once again, you will be able to see that we have already launched our DSA 2.0 batch, and the seats will likely to be filled up very soon. So if you are someone who is interested to learn DSA with me, because so many requests came up, I don't have initially the plan to launch this course, but because of the multiple requests by multiple people via LinkedIn, via mailing me personally, because of that, I have launched this batch. So again, thank you so much for all the support. And if you are someone who is really curious to know what are the things which I will cover up in that specific course, I will attach the link of the course in the description of this video. You can just check it out, the page. And if you are having any sort of doubt, any sort of trouble, you can directly reach out to me via my email. Again, the email ID is also available in the description of this video. Enjoy this video where we will be discussing about naive Bayes, mathematical intuition, SVM mathematical intuition. The interesting thing is, many things which I am discussing in this specific video, you will very widely used and will face a lot of interviews in the technical rounds as well with respect to machine learning. And many people usually say that nowadays we are having a generation where things are moving in a very fast pace with respect to generative AI. So is that required to learn machine learning still? I'm planning to curate a separate video for that, but just to answer in a brief context, yes, it is required, because ML is the foundations of Gen AI as well. Although the tools will be upgraded in future as well, some new things will come up in AI specific domain, because things are changing in a very fast pace, but the foundations will always remain the same. So please make sure you will, if you're a beginner, don't be in a race to get the shortcut and start learning via the upgraded things or tools. Yes, you can learn directly, but definitely in future you will face a lot of trouble. So please make sure that you will get the mathematical intuition aptly. You will get the learning foundation so strong, so that if in future new things will also come up, you will be easily able to learn it and accommodate yourself accordingly. Be flexible enough to learn new things as much as you can. And with this, let's jump towards the mathematical intuition behind naive Bayes, KNN, and SVM, support vector machine. I'll try to attach the timestamp in the description of this video. If you want to skip any of the portion, you can. Otherwise, please watch it till the very end, and I hope that you will like it. So let's get started. So basically, when we are talking about this naive Bayes algorithm, in the mathematical part, we have one topic uh, in the probability per se by the name of Bayes theorem, or Bayes theorem, people say. Have you guys already aware about this theorem, how it works, what's the intuition behind this theorem?
Yes, ma'am.
So anyone can explain to me what this theorem says, how it internally works, what's the intuition behind this theorem?
So it basically depends. So the Bayes theorem is like we have to find the probability of
Mhm.
of an event given some other conditions have happened.
Okay. Okay.
Like if we have some if you have some events like x1, x2, x3, and they all have their probabilities like the occurrence of that event. So
Mhm.
based on this, we can find the probability that a certain event will occur given that another event X has happened.
Yes, correct. Yes, it is correct. So basically, what this Bayes theorem says? It says that the probability of any event A, given that B event has already happened. So this is the interpretation of the statement which I'm writing. Probability of A slash B I'm writing, right? This is the interpretation is the what is the probability of A given the event B already happened. Okay, there is a conditional probability. We also call it as a conditional probability. There is a condition behind that, that B is something which has already happened. Then what is the probability of A? And the formula to calculate this is nothing but what is the probability of A intersection B divided by what is the probability of B. So this is how basically we will be able to get the uh, intuition behind the Bayes theorem. This is the major formula which you will be able to see quite a lot many number of times. Also, if I'll ask you, what is the probability of B given A? With reference to the above formula, can you give me the answer?
Probability of B intersection A by probability of A.
Yes, probability of B intersection A or A intersection B is one of the same thing divided by the probability of A. So can I say that this probability of A intersection B or B intersection A, we can also write it as, if we'll do the cross multiplication, probability of B given A into probability of A. Can we write like this? Does everyone agrees with me on this point? So what I will do is I'll try to just do an intuition here that we can also write this formula of probability of A given B as, if I'll just replace this probability of A intersection B, we will be able to get the answer as probability of B given A into probability of A divided by probability of B. And this is the final, you can say, formulation of a formula which we are using in the naive Bayes maths. So, is that formula intuition is fine for everyone? So, probability of A given B, we can also find out by computing what is the probability of B given A into probability of A divided by the probability of B. Is that making sense to everyone? Till so far, things are sorted. So my final formulation is that when I am computing the probability of A given B, I'll compute what is the probability of B given A into what is the probability of A divided by what is the probability of B. Is it fine for everyone? Till so far, things are sorted. Any
Yes,
doubts?
ma'am.
ठीक है. Now, in naive Bayes classifier, what it says is that, for example, in the recorded sessions, I have taken one example of a Outlook based data, if I'm not wrong, right? So let me just open that data sets naive Bayes classifier algorithm. So I think this was the data, right? Outlook Sunny. So Outlook, or might be I do have an image of that if I'm not wrong, because I have done the recording. Let's see, naive Bayes algorithm. I think this is the image. So I was working with this data, right, in the recorded video. And here, if you will be able to see, for example, let's say if someone is saying to me that Priya, the outlook is sunny, let's suppose, the temperature is hot, let's consider, humidity is suppose high, let's say, and windy is, let's say, false. So, what will be the answer? Whether a guy will play a golf or not. So, there are four conditions which is given to us. On the basis of that, either the person will go and play a golf or the person won't go. He will avoid playing golf. So, depending upon this particular constraint which I'm writing below, sunny, hot, high, and false, whether the answer is yes or no, that is the kind of a problem which our naive Bayes classifier will try to solve. Now, how basically we will solve that? The simple intuition which naive Bayes says, it's one of the easiest algorithm I will say, till so far whatever we have discussed. But to understand this algorithm, you should have a very good understanding of the concepts of probability. That's the simple intuition which it is providing to us. What it says is that what you want to find out the probability of, what we will do, we will try to find out the probability of yes, because we have two classes. Let's say if in future we are working with a multi-class classification problem, and let's say we will be having three classes. In that case, what will happen is you will try to find out that many classes probability. So always remember, in the naive Bayes classifier, it will just count the labels. So it will count the labels. For example, in this particular scenario, we have two labels. One is yes, another one is no. Either yes or no. So what this naive Bayes classifier says, it says that find the probability of yes given that the outlook is sunny, the temperature is hot, the humidity is very high, and the windy is false. So what is the probability? Can you let me know? And then it will try to find out again the another probability of no given all these constraints, which is sunny, hot, high, and false. Now, the simple idea or intuition is in this naive Bayes classifier is that whichever is having a highest probability, that will be the one which will be the final result or which will be the prediction by the model. That is the simple intuition by this naive Bayes algorithm, which says. Now the question is that how can we compute if we will be having multiple features? Because here I have just in the formulation of the formula shown you just single input feature, right? Probability of A given a single feature is given to us. Now let me just first of all reformulate this formula by asking from you guys, what do you think is the probability of A given, let's say, four input features, because we're working with the four input features here, x1, x2, x3, x4. How will your formula will get changed as per this intuition which I just now have shared with you? Let's see who can tell me the correct result. If let's say in the conditional probability, instead of having single yes, single input feature, I will be having multiple conditions. So how will my formula will get changed as per the below one? Any answers? Can I expect?
Ma'am,
This is simple maths. Uh-huh.
probability of x1
Okay.
given A or
Okay.
given yes, then
Yes, it's correct.
into yes,
Probability of x1 given A,
then into
into
probability of x2 given
x2
A, yeah,
given A, into
into probability of x3 given A,
correct
then probability of x4 given
given A,
A
into
into probability of A, ma'am.
probability of A divided
Yeah.
by
Probability
complete
of yeah, x1a x2 sorry x1 probability of x2
x1 into
probability
probability
of
of
x2
x2
probability
into
of x3,
probability of x3 into probability of x4.
yeah,
So whenever we will be having multiple input features, so you will see in the mathematical standard books, they will use to write this pi symbol. Summation of I equals to 1 to, you will be saying n. N is the number of input features you have. And pi indicates not summation, you can say I value. So pi indicates the multiplication of the given values. So what I'm trying to convey is that with the help of the multiple input features that you have, so your formula will get changed where you will try to take individual's probability given this value of a, multiply all of them into the complete multiplication of probability of a, divided by, again, if you see, because here I was having a single entity, so I have taken just probability of this. But because now I will be having multiple conditions available, I'll take the probability of all of them and multiply. So this is the formula which we will be able to get. Does it make sense? Till so far, everything is clear mathematically what I have written. Any doubts? ठीक है. I hope then it is clear. There is no doubt. So now, what will happen is the ultimate idea of the complete talk is to compute now what is the probability of yes given Sunny. So as per the above intuition, above result which we have formed, what we will do is we will try to find out what is the probability of Sunny given yes. Now you will not get confused because we already have written it. What is the probability of temperature as hot given yes? I'm just copy pasting the above context here as per this values. Consider that this is our x1, x2, x3 and x4. So this is why we are doing like this stuff. What is the probability of high given yes? What is the probability of windy as false given yes? Into what is the probability of complete yes? Divided by, in the denominator, we have what is the probability of sunny into what is the probability of temperature as hot into what is the probability of, you can say, humidity as high, and into what is the probability of the last thing that we have is windy as false. So now we will try to compute this particular value, which will give me indirectly the idea of what is the probability of yes, given all these four input features, which is sunny, hot, high, and false. And same thing we will do for the probability of no as well. The only change which will happen is that in the conditional statement, when we are saying given yes, we will say given no. So another thing which we have to compute is the probability of no given the outlook as sunny, temperature as hot, what was another thing? Humidity as high, and windy is false. So we will try to compute. This will be nothing but what is the probability of sunny given no into what is the probability of hot given no into what is the probability of high given no into what is the probability of false given no into what is the probability of no divided by complete multiplication of the probability of sunny into probability of hot into probability of high into probability of false. Till so far, is that making sense to everyone? Whatever I'm writing here, or is that a complex statement which I'm writing? Now it is easy. Now the main thing which we have to do is to find out these four numbers. This. One thing which you will be able to observe, that denominator part in both of the equations are same. This equation and this equation we are comparing. Whosoever will win, our model will give that as a target result. Now, because the denominator is same, so do you think when we are doing a comparison, does that make sense to compute and do the division? Why to make a complex calculation? Because anyhow, if you are dividing any term, any two terms, for example, it's simple maths, you can just assume, let's say, we are saying we have a answer as 2 and then we have 4. Let's assume we have answer as 2 and as 4. If you will divide the answer with the same term, I'm saying 2 is less than 4, let's suppose. And then I'm saying I'll divide this both the terms by 2. Does that comparison will get changed? No, it will be always makes true only, right? It's again a simple maths you have to use. What I am saying is, if you are comparing two terms, and let's say you are comparing the numerator, and the numerator part is bigger than the other one, if you are dividing that numerator term with both the similar values, so does that comparison will be impacted, or it will remain the same? What do you think? It will definitely remain the same. So, to make the calculations easy, what researchers have done in that algorithm is they have removed the denominator term altogether for the comparison per se, and they're just focusing on the numerator part. So, this is what we will do also. We will just focus on the calculation of the numerator part, and whichever value is bigger, we'll take that as a final value for the yes or no. Does that make sense? Okay, cool. Can you guys give me the confirmation in the chat window or by unmuting yourself? Shall I proceed? Perfect. Now, let's try to focus on the computation part, which is the final major role which we have to do in this complete mathematical part. For that, what we will do is we will try to curate a table separately for all the features that we have. For example, we have Outlook. So the image which I was referring at the time of recording and which was wrong is this image, which I have picked up from that, you know, Geeks for Geeks page. Also, I have told to them, I connected with them and I told to them to change this, because when people will refer your page, they will find it inappropriate, which doesn't sound good. Might be they have now updated also, I'm not sure. You can just refer it again, or maybe let's see. Because I complained and I just connected with the team and then told to them that please do this part again. Did they removed? No, it is there. I think it was previously only. Anyhow, what was the mistake? Now let's try to see. The mistake was, for example, here, this is what I was saying. We need to curate a separate tables for all the parts: outlook, temperature, humidity, and wind. That is fine. Till so far, everything is fine. If you will just count it out, how many records are there with sunny and yes? How many records are there with sunny and yes? So you will see 1, 2, 3. And for sunny and no, there are 2 records. So if you can see, this is also fine. This number is also fine, 3 and 2. The problem came here, actually. What is the probability of yes with respect to the sunny part? So if I'll ask you, what will be your answer? Is that correct? It is saying 2 by 9. What is the probability of yes? If I'll ask you, given this table where I will be having 3 records belongs to sunny and yes. So what is the probability of yes?
3 by 9.
It should be 3 by 9, right? So that is the wrong mistake part which is there. And that is what I highlighted in the recorded video, but I figured it out in the very late recording part, and that is the issue. Might be some confusion happened. I'm also planning to re-record that video again so that this confusion won't be there in future. Whenever I'll do the re-recording of the video, I will upload the updated version of that. Same thing happens here. The probability of no should be, can I say 2 by 5? Will you guys agree with me?
Yes, ma'am.
Okay. Now, one other confusion is there, which again I'm seeing here. Again, see, overcast, how many number of records are there? Let's focus on now overcast wala part. So they said overcast 4 yeses are there. Let's see. 1, 2, 3, 4. So it is fine. So what is the probability of yes? It will be 4 by 9. What is the probability of no? 0 by 5. So this part I think is very much apt. Now let's focus on this rainy wala part. They are saying 3 are yes and 2 are no. Let's try to verify this part also. 3 are yes, 2 no's, 3 no's are there, if you can see, and 2 yes are there. So that is also wrong, which they have specified, this vice versa. 2 are yes, 3 are no. So you will be able to get completely different probability now, 3 by 5 and 2 by 9. Is it correct now? That is the simple thing which you have to understand. So if you will be able to see, in the rainy and yes, we have 2 records. So accordingly, I have updated here. Is it fine? So if you will see, we have 3 records, 1, 2, 3 belonging to rainy and no, and 2 records are there, rainy and yes, belonging to yes wala part. Accordingly, we have to modify the probability. Is it fine for everyone? So we will be having 2 by 9 as the probability of yes and 3 by 5 as the probability of no. So in total, we will be having how many number of yes? 9. How many number of no? 5. Till so far, things are sorted. Any doubt? Same thing you will verify for the temperature per se. I think remaining tables are very much apt. 2 by 9, 2 by 5, 4 by 9, 2 by 5, 3 by 9, 1 by 5, 3 by 9, 4 by 5, 6 by 9, 1 by 5, 6 by 9, 2 by 5, 3 by 9, 3 by 5. So basically for every particular feature that we have, we are just looking into the how many number of yes are there, how many number of no's are there, and what is the probability of, for example, sunny given yes, sunny given no, overcast given yes, overcast given no, same thing, humidity as high given yes, normal given yes, everything we have already evaluated. And finally, what is the probability of yes and no individually? So we know 9 number of records are there belonging to yes, 5 number of records are there belonging to no. So this is 9 by 14 and 5 by 14. So this is the overall picture which we will be able to get for now. So is everyone is comfortable till so far while looking into this picture now? Any doubts here? I think whatever doubts you guys have must be on this table itself, because otherwise everything is just a calculation. Now so we just have to feed these numbers and just have to do the calculation, and we will be getting the answer. So is it probabilities chart which just now I have showcased you by doing some modification is clear to everyone now? Mayank asked the question, I think, or Manoj asked the question. I don't remember. Is it clear now?
Yes, ma'am.
Okay. Now let's try to do it then fatafat se. Now the calculation is what we have to do. It's very easy. Sunny given yes. Can you guys give me the answer? Sunny given yes. This answer. Sunny given yes. What is the probability? Can I say 3 by 9? Yes? Everyone? So can you guys speak up now? Hot given yes? Hot given yes?
2 by 9.
2 by 9. High given yes? High given yes?
3 by 9.
3 by 9. False given yes?
6
False
by
given
9.
yes? 6 by 9. What is the probability of yes?
9 by 14.
9 by
9 by
14.
14.
Can someone do the calculation on this? Maybe you can use a calculator and give me maybe 2 precision value. Means after decimal, 2 places should be there. 2 decimal values. Meanwhile, someone can do this calculation. We will move ahead to the next number. Sunny given no. What is the answer? Sunny given no. What is the answer?
2 by 5.
2 by 5. Hot given no. Hot given no. What is the answer?
2 by 5.
2 by 5. High given no. High given no.
4 by 5.
4 by 5. Perfect. And then we have false given no.
2 by 5.
Probability of no.
5 by 14.
So I'm just writing both of them. 2 by 5 into 5 by 14. And can someone does this calculation also? We'll get some number here also. Let's talk about two decimal places itself in both the cases. So
Ma'am, I guess the first calculation is 0.0035.
now I'm not verifying. Please do verify at your end. Do this as well. 3 times 2 by 5 into 4 by 5 into 5 by 14. What is the final result?
Zero point zero 0.018, I guess.
0.01.
01.
Okay. So now, as per this comparison, if you can see who wins, the probability of no, right? So what was the result in the recorded videos? Is that same? Three into 2 by 5 plus 4 by 14. Is it correct? 0.01. It's fine. 0.018 I'm getting. And this one is 3 by 9 plus 2 by 9 plus 3 by 9 again plus 6 by 9 plus 9 by 14. Oh, I'm doing, oh, it's multiplication. Six by 9, 9 by 14. I'm getting 0.0105. Can someone verify? I'm not getting this answer.
0.0105.
0.0105.
है ना? This is the answer I'm getting. 0105. Just verify this one also. Is that correct? 0.018. So, as per, if this is the correct calculation, this one is the winner, right? So, if someone is talking about this particular result, that whether a person will go to golf or not, so it might be no itself. The output of my model will give the prediction as no. It might be the case that in the recorded video, I might take some different parameters, then the answer obviously will be different. So just make sure what is the input features we are passing, and that according to that calculation will be changed altogether. So that is the intuition behind the complete flow of naive Bayes classifier. Uh, Again, please recheck at your end the calculation part. Might be there is some mistake, but I think you can verify. But I have verified. It is the answer which I am getting currently. You can just verify at your end also. If there is something mistake, you can just let me know. We will change the documentation accordingly. Till so far, things are clear. So this is how the complete naive Bayes classifier works. Simple, easy, right? Uh, Now, The important thing which you have to understand in this specific naive Bayes classifier is that at what point of time usually people prefer to go with this algorithm, and what is the major problem in this algorithm where people usually don't prefer to go, right? Two instances where it is preferably used and where it is not being used widely, right? That is something which we have to understand. But before jumping to that aspect, is that whatever maths I have shared till so far is pretty much clear to everyone? Any doubts till so far? Anyone? Whatever things we have discussed, very simple, right? Nothing complicated. If you know, again, I'm saying this is the prerequisite of naive Bayes, probability. If you know how can we compute the probability, which is nothing but number of instances which are happening divided by total number of occurrences. If you are comfortable with that, to how to compute with the conditional part, then the things are very, very easy. Any problem till so far? Okay. Let's go back to this page. Here they are talking. This is what I was talking about. See, so in the mathematical sense, if you will go and refer any standard book, oh, where it went, you will find this kind of pi symbol will be there. So they have also mentioned the same thing. So that is something which is important to understand. These are the terms which people say priori analysis, posteriori analysis. So you can just try to refer this documentation first. Whatever mistake is there in that table itself, otherwise remaining things are very much apt written. So you can refer this documentation of Geeks for Geeks, very well written in terms of understanding per se. Now, one thing is the assumption of this algorithm. What are the assumptions majorly? So if you will be able to see, first assumption which this classifier says is that the features of the data are conditionally independent of each other. So it means that given the class label, for example, in our case, we're talking about a play golf. So whatever with the input features we have, for example, humidity, for example, windy, for example, temperature, for example, outlook, everything should be conditionally independent of each other. Then only you can apply this naive Bayes. The features are normally distributed. So here, if you will just try to plot the distribution of the features, and if those features are continuous, that is something which you have to make sure. For example, just now the discussion that we have made is of discrete features, right? Discrete features meaning that we will be having a separate classes altogether. In continuous, I hope everyone knows we have some continuous number available with us. For example, that not windy, quality data in the wine that we have done in our previous discussions when we were talking about the implementation of decision tree. I hope you all remember. In that, we have few input features. For example, citric acid was there, sulfate. There are multiple features that we have, right, in that kind of a data set. So that was a continuous feature set. So in that case, we have to check the distribution of each and every feature. So it should be normally distributed. Then only you can apply this naive Bayes. Discrete features have multinomial distributions. So, see, in this specific algorithm, you should be aware about the different kind of distributions that we have. I'll talk about and come about this point also that for this, it requires a knowledge of random variables. There are majorly two distributions we have in random variables. One is, you can say, discrete, another one is continuous. So when we are talking about continuous, normal distribution is a part of a continuous random variables. And this multinomial distribution is a part of a discrete random variables. That is where the concept of PDF, PMF, which I was talking about, came into picture. I'll let me talk about that in a future part today. Then features are equally important. So here we are assuming that all the features are contributing equally when we are doing a prediction of a class label. So in this specific case, what they want to say is that feature engineering or the selection of the crucial features are very, very important. You have to just check it out before applying this naive Bayes classifier or before going to a stage of data modeling. Just check it out that whether every feature is contributing equally or not. And if you find there is some features which are not contributing that much, you can just remove them. Now, you can also find the feature importance value via the algorithm of random forest and decision tree. With this, I just remember, just right now, we have to discuss the maths behind that feature importance value also, that is pending. So today, let's discuss that part also. So although I have just showcased you in our last discussion that feature importance value we will be able to find out with respect to every feature, and with the help of that also we will be able to understand that whether all the features are contributing in an equal proportion or not, and there should not be any missing data. So I think these things you will be able to determine via the EDA itself. So whenever you are planning to apply the naive Bayes algorithm, just try to check in your EDA that all these properties are fulfilled or not, right? One thing here you can see with relation to our data set, because that is what we have also used, we assume that no pair of features are dependent. For example, temperature being hot has nothing to do with the humidity. So that is the assumption that they have made. For example, you can say that Priya, you are talking about the independence here, but whatever with the data you are using, in that case, we will be having a humidity also and temperature also, and somehow they must be correlated. But they are making some assumption here, and that is why they are using that kind of algorithm. So that is something you have to make sure, right? Each feature, then they are assuming that's the assumption that they are having a same importance. Then they're talking about this Bayes theorem. I have already shared what is that all about. For example, they have taken the sunny, hot, normal, and false. I think this is what we have taken in our discussion today. No, we have taken high as the temperature. So there is a different result which we will be able to get. Humidity as high we have taken. They have taken as normal, although their table was also wrong. So definitely they will be able to get a wrong result. But anyhow, you can see they're comparing. And after that, you will be able to see whatever be the value they're getting as a bigger, they will mark it as that is the final output by the given model. One thing you will be able to observe, that is again an optional step, is to do the normalization. So what is the meaning of normalization? Simple meaning is that what we usually have the concept that what is the probability, whatever the probability of yes and no we are getting, right? Probability of yes given the value of x1, x2, x3, and x4, plus the probability of no given the value of x1, x2, x3, and x4 should be equals to 1. Because but anyhow, because when we remove the denominator portion, it is not equal to 1. You can see, right, the answer is like that, 0.0105 and here 0.018. So we can normalize these values. How basically you can normalize? You can try to apply a weighted average over this probability by saying what is the probability of yes? It is 0.0105, 0.0105 divided by the probability of yes plus no. So you will be able to get 0.0105 plus 0.018. Similarly, you can try to do the same thing for this proportion also. And when you do this normalization, then the summation will be equals to 1 only. So this is 0.018 divided by same thing, 0.0105 plus 0.018. So can anyone evaluate what is the answer we will be able to get in both the cases? Please do this. So this is what they are doing. They will be getting this term. It's nothing but is the normalization part. Numbers can be converted into a probability by making the sum equals to 1, which is what we call as normalization in maths. And then we can compare the probability of both of them, whatever numbers we are getting, and accordingly the prediction will happen. So you can just recheck at your end whatever be the values we will be able to get after normalization. But anyhow, things will remain the same. Whatever is bigger, it will remain bigger only. So accordingly, the predictions will be made. So this concept, core concept, is called as normalization. Done. So far, so good. Everything is clear, whatever we have discussed till so far. Any doubts? Anyone? Let's talk about the disadvantage of this classifier. Advantages, I think you must be, after looking into this maths, might be able to get an idea. It's very easy to implement and computationally efficient. It is effective in the case where we will be having a bigger number of features, performs well even with the limited training data. In the presence of categorical features, it performs well. For numerical features also, it is assumed to come from normal distribution. So basically, all these are the, you can say, pros of naive Bayes, which we have also, I think, get an intuition with the maths behind that. The important thing which we have to understand is the disadvantage of this algorithm. First thing is, it assumes that features should be independent. But in the real world data, whenever you will work with, chances are very less that you can make this assumption or this holds true. Features might be dependent to each other, and wherever there will be a dependency, you cannot apply this naive Bayes. One thing is this. Second thing is, it can be influenced by relevant attributes. I hope you all remember the assumptions. So it's very, very important in this naive Bayes algorithm to understand that which feature is highly important and which feature doesn't make sense at all. Means feature selection is really important in this naive Bayes algorithm. And if you will not do well, your results might affect, right, with the irrelevant features that you have. This is something which is very important out of whatever things we're discussing here. It may assign zero probability to the unseen events, leading to poor generalization. What is the meaning of that? This is where people get confused. Just try to understand this point, and I think that is the important, crucial point which I want to indicate here. You can see this case, right? If I'll ask you what is the probability of overcast as an outlook given the value of no. So what is the answer?
0, 1.
0. Now, consider that at any point of time, if this kind of situation will happen, and if you're multiplying this term, when you're evaluating, let's say, the probability of no, given, let's say, outlook as overcast, temperature as, let's say, mild, humidity is, let's say, high, and windy is, let's say, false. So what will happen is, just with this one single feature, because we will try to compute the value of probability given no, whole answer will be 0. So do you think it's a good generalization? Do you think, does that make sense? Let's say we are working with the multiple features that we have. What is happening is, because we are working with the probabilities, and if any single probability is 0, we are not doing addition here, we are doing multiplication here, right? So if one single probability is 0, it will lead to the entire result as 0 without considering the other values, other results in the temperature part per se, humidity per se, wind per se. And you can imagine, maybe let's say we are working with 15, 17 features in our real world data points. So with a single feature itself, if by chance they will not have any records, complete generalization can go wrong. It will be poorly generalized in that scenario. That is the, you can say, major limitation or disadvantage of this algorithm. Although after that, researchers came up with few research papers where they tried to avoid this problem by saying that let's try to add +1 in all the tables, in all the values of the records, so that the result will not impact. And if there is any record which will have 0 value, that problem will get resolved, because at least a single record they will be able to have. Similar to that, they come up with multiple solutions, but still the main approach is this only, because you are interrupting the original records in that approaches. But issue is, if we will not interrupt the original records, and if we will make it sustain and will try to apply this algorithm, it might be the case that for any given feature where the records are not available in your real-time data, complete generalization might go wrong, and that is what this last point signifies. It may assign 0 probability to unseen events, leading to the poor generalization. Is that making sense? This is very, very important. So if someone will ask you what is the disadvantage of naive Bayes, please talk about this a lot, because this is the major thing which I think interviewer also wants to listen to you. And if at any point of time you have implemented this algorithm in a real-time data set, uh, this problem comes quite frequently, and people, that's why, usually try to prefer to go with other algorithms instead of naive Bayes in that case, right, where chances are very high that we will be able to get the zeros or missing values available within our data. So in that case, naive Bayes is not that much efficient algorithm to work with. Maybe going towards random forest or going towards the boosting algorithms that we will discuss in the upcoming sessions like XGBoost is a better idea. Is it make sense to everyone? Fine. Also, please, after this discussion, make sure you will just refer this particular part. Try to read everything, whatever things are given. I cannot try to study each and everything with you, because otherwise we will be not able to move ahead. Even though I want, but still I can't. Just I'm showcasing you few important things in this documentation. Remaining things you can refer. Majorly, you will be able to observe that this algorithm in the real world, people are applying. So in the real world scenarios, you will be able to see majorly in the spam classification per se in our emails. When the filtration will happen, it is done by this naive Bayes classifier is working internally. In the text classification per se, again, this algorithm is working very, very widely, right? Chances are very high if you will see the documentation, naive Bayes is working quite appropriately. Because again, because in this kind of scenarios, getting that zeros problem or getting that issue of missing values is very, very less. So that is the main reason that in the industry per se, people are using, if they're solving these kind of problems, this naive Bayes classifier. Apart from this, in the financial domain per se, in the credit scoring, also naive Bayes classifier is being used. You will see in maximum companies they're using this algorithm, apart from the algorithm of XGBoost and random forest. Make sense? Shall we proceed now? So this is what the applications they are also talking about. I think now let's talk about few stuffs which someone was asking also to me. If you will go to the naive Bayes classifier documentation, you will see that we have multiple algorithms in the naive Bayes algorithm documentation. If you have ever opened it up, you will be able to see the complete idea behind that. So here you will be able to see the complete maths is same, but depending upon what kind of data you will be having. For example, if you are dealing with a continuous set of features which are in a normal distribution, you will always go for this Gaussian naive Bayes. So Gaussian NB is the method name which you will call. If you're dealing with a discrete features, as in the play golf we have a discrete set of features, in that case you will go with a multinomial naive Bayes. Again, we have complement naive Bayes. You can see it's basically applicable whenever you are dealing with the problem of imbalanced data. So this complement naive Bayes handle it very well. Bernoulli naive Bayes, you will go whenever you are having a data in which you will be able to see that data is somehow distributed with the binary values, true or false, right? Now, why this kind of namings are being given? See, usually, as I told you, that we have in a maths some concept of random variables. Again, if you will refer the topics of linear algebra, discrete mathematics, you will be able to find these topics quite frequently. What is the meaning of random variables? Any idea? Anyone? What do we mean by random variables? I hope that you must have heard at least this term, random variable. So what is the intuition behind this random variable? Anyone can let me know? What do you understand by random variable? I know this is a maths topic, but still, you must have done
A variable
Hello,
that can take on different values.
any
Priya.
example via which you can explain. I think this is correct. Yeah, you are going in a correct direction. But if you will tell this part to anyone who is not in the maths background, they won't be able to understand. So, can you
Um,
explain via some example?
when we are flipping coins, basically, let's suppose we are flipping two, or let's suppose we are flipping three coins. So the possible values can be z- um, one, the triple head, basically triple tails, one head,
Hmm.
one tail,
Hmm.
like that.
Hmm. Hmm. Yes.
So these are
So, correct. After doing an experiment, in an experiment, you will be getting some different values, some different probability of getting that. For example, Mayank has given a very apt example, but let me simplify more. You are having a single choice. Sorry. You are having a single coin and you are just doing a toss with respect to that. So when you are tossing that coin, what is happening is, if I'll ask you what is the probability of head in that coin and what is the probability of tail, your answer will be
0.5, 0.5.
1 by 2, 1 by 2, or 0.5, 0.5, right? So as per the given experiments, your probability is coming up with some different numbers that you will be able to gain, right? Now, when I'm saying that you will be having a probability of head or tail as 0.5, 0.5, these kind of examples where you will be having, you can say, almost an equivalent probability, there are 0.5, 0.5, chances as head or tail, nothing like that, other numbers, some continuous numbers will not be there as an output. This is called as discrete random variables, because your final value will be a discrete value, either it will be head or it will be tail. But you are doing some experiment, and at that experiment you are just trying to find out as an output the continuous value. Any real time example can I give you? Let me think. For example, let's say temperature of a room. If you will ask that, currently let's say I'm sitting in Bangalore,
Weight
what is
of
the
the person.
temperature of a room? Simple. It will be a continuous random variable. It will be a part of a continuous random variable. And as per the given results, either you're getting discrete values or a continuous values. Depending upon that, we have different categories of random variables, as I have just now discussed. One we have talked about is a discrete random variable. Another one I have talked about is a continuous random variable. Okay. Few days back only, I think someone asked me in a Telegram group regarding the uh, mathematical part per se, where should I learn and practice. I have shared one playlist link of Gilbert Stang in the uh, standard notes, also in the dashboard itself you will be able to access, and other YouTube channel also by the name of Purohit. I think that's his name. I was not currently following his channel, but I remember when the time at the time when I was learning mathematics, that channel helped me a lot. Like, it was few years back. So you will be able to get this understanding in a lot more depth if you will refer that channel, because obviously I cannot teach you this maths also in a lot more depth. So I'll just try to showcase you the concepts here, but that is a brief. You can just try to refer these videos in his channel. You will be able to get a very good understanding of all these stuffs in a lot more detail if you have the time, because these things you should know. And these things will really help you to get the understanding in future also, when you will move ahead with respect to the uh, further deep learning stuffs also, because the kind of data distributions which we have, what kind of distribution it holds, what is the kind of results we will be able to get, this knowledge will always remain the same, right? You might have a discrete random variables distribution, or you might have continuous random variable distribution. So you should have the knowledge of all these different distributions that we have. Majorly used, I think this is something which is very important, is the normal distribution in a industry per se. Also, if you will ask me, Priya, which one is the distribution which is quite heavily being used and I should have an in-depth knowledge of, that is the normal distribution. Now in this distribution you will always get some continuous result as an output. If you remember, we already have discussed this distribution. It's kind of a bell-shaped curve where, if you will see in the mid, the value of mean, median, and mode will be equal. Might be it doesn't sounds like that in the picture, but still this is what the intuition behind the normal distribution that we have. Now what is happening is, for example, in the discrete random variable, the distribution, for example, Bernoulli is the discrete one. Just now I have discussed, right? Bernoulli distribution. It is being used whenever you are dealing with a binomial, not binomial, binary values. Whether the values will be 0 or 1. At that point of time, Bernoulli distribution is the one which is working internally. Multinomial distribution is again where you will be having a multiple discrete values available in your data. So, and many more in both the stuffs are there, kind of distributions. Here also, many more are there. But what I'm saying is, depending upon in naive Bayes, what kind of input features you have, there are separate classes which they have designed, researchers have designed, and they have mentioned in the documentation. Now, what usually happens if you're working with the continuous random variables, then you will be having for every distribution the value of PDF. This is called as probability density function. And same thing in discrete random variable is called as PMF, probability mass function. Both of them are under the umbrella of PDF, probability distribution functions. So some people usually get confused and they thought that this probability distribution function and probability density function, both of them are the same thing. No, they are different. Probability distribution is the main leader, you can say. And in that, we have two categories, PMF and PDF. PMF belongs to the distribution of discrete random variables. PDF belongs to a distribution of continuous random variable. What is the significance of that? Simply speaking, for example, if let's say I will provide you some given data set and you have to convert that data into normal distribution. So there should be some function, right, via which we will be able to do that conversion in any of the scenarios, whether it's a discrete random variable distribution or whether it's a continuous random variable distribution. So what is happening is we have for every distribution some function linked with that. In normal distribution, let's say we will be having f of x, which is equals to, which you will be able to see here itself, right? This is the function. Can I just copy this up? Or one or other thing also I can say, PDF of normal distribution. And let me go with the image. This is actually, I think let's take this image, not this one, this one. Save image. And this image will help you to understand both the concepts. Done. So this is the f of x value or PDF value of, you can say, actually this is the one I want to pick up. This one. Let me write like this. So this is something which you have is a normal distribution formula for this. This is what we call as PDF, probability density function. So if let's say I will provide you some data set in the form of xi, and if let's say I'll say that can you convert that data into a normal distribution form, you can, right? We have a function. Every distribution has its own associated function, which is what you are calling it as either PDF or PMF, depending upon which distribution it holds. Is that clear till so far? Whatever be the thing I want to convey here. So here you can see 1 upon sigma is the standard deviation. Everything is written. That's why I have taken this picture. Square root of 2 pi, exponential of minus of xi is the input data value, which I'm saying, which is given to you. And let's say you want to convert that input values in the normal distribution form. Minus mu is the mean of the data points and sigma is the standard deviation of the data points. If I'll just try to give you one simple example, let's say you are saying that Priya, I will be having one data in which the feature is age. And in that feature, let's say the age is 23, 47, 74, 46, 32, and multiple points are there. For example, in this way, we will be having 10,000 records. And when you try to form the distribution of this original data, you are saying that it is a skewed one, or it's not a normal distribution. But I want to convert this distribution to a normal one. So can I convert that? Yes, you have to apply that f of x of a normal distribution. You will have to compute what is the mu of this, what is the sigma of this, whatever be the value you are getting with the mu and sigma, you can just apply. Xi will be 23 in the first case, 47 in the second case, 74 in the third case. So for every data point, you will be able to get a appropriate normal distribution value available. And if you will plot that distribution of f of x, which you have plotted by this formula, that will be in a normal form, that will be a bell-shaped curve. Does that make sense, what I'm trying to convey here? Same picture will be there for all the different distributions that we have. So in a probability distribution function, I'm again repeating, we have two different categories, PDF and PMF. PDF belong to continuous, PMF belongs to discrete. For every kind of a distribution which is under the category of a continuous, it is having some function which is called as a PDF, probability density function. In discrete also we have a functions for every distribution which is called as PMF, probability mass function. That is why you will be able to observe that in this case, they are representing even by P of xi given y, because it's a probability function only, but it's a density function because it's a part of a Gaussian normal distribution. Gaussian or normal, it's one and the same thing. Don't get confused with the words which are mentioned here. So is that discussion of PDF and PMF is fine? And if someone will ask you the difference between probability distribution function versus probability density function, although the short form is PDF in both the cases, will you be able to explain to them now what is the difference between these two in future? Is that comfortable to everyone? Any doubts still so far? Perfect. Now, you must have heard one more term called as CDF, cumulative density function, and cumulative mass function. So on top of this PDF, we have something called as CDF. And on top of this PMF, we have something called as CMF, cumulative density function, cumulative density function. So what is happening is, let's say you will be able to get the results for individual probability density function. For example, for this case, you will be able to get the values available in each and every instances, right? By doing a conversion, by applying this formula. If you will just keep on adding these values, for example, in the first case, you're getting 0.02, in second case, you're getting 0.04. So you are saying you are trying to plot a graph where first cumulative value is 0.02. Second cumulative value will be the addition of 0.04 plus 0.02. Cumulative means that you are doing an addition of all the values of PDF or PMF as you're progressing. So that is why the previous picture which I have showcased you, now I will just open that picture now in the below part, and then you will be able to understand it in a better manner. Let's see this. So here you can see what is happening is now it is just doing a integration to all the values of from minus infinite to the x in the cumulative distribution function. So we have PDF for every distribution, then we have CDF. So in CDF, we're just integrating, we're just adding all the values of probability density function. That's it. That is why the name cumulative is given to that particular part. So when you are doing a integration, I think you all know in the calculus, integration means adding in a way all the values all together. So that is what we are doing.
We can also say area under the curve.
We can also say
Area under the curve.
yes, yes. Does that make sense now? Now this is I would say limited information which I have given you. What you can do is at your end, you can just explore for every kind of a distribution, what is the value of PMF or PDF, what is the CDF looks like. Again, don't need to remember these stuffs. Even you can't, because there are lot many distributions that we have. But the core idea will be that you should have a knowledge of these things. If I'll ask you today from you guys before this discussion, are you guys aware about these things? Are you guys have a knowledge internally end to end, the idea of PDF, PMF, CDF, CMF, the idea of probability distribution functions, the idea of random variables, although you must have learned it in your discrete mathematics classes in your BTech, or if you have done masters, definitely these topics may come. And I don't remember exactly, but in the 11th 12th classes also we might have these topics. I'm not sure, I don't remember exactly, but I feel that we do have these kind of topics available. So at any point of time, I think you must have learned these topics, but you might don't remember these. So I'm just saying that after this discussion, first thing, I think now things will be pretty much clear to everyone. What is the core idea behind all these things? Still, I'm saying just explore, and you can refer those videos which I have shared in the Telegram group, his channel, where he's exploring and talking about individual distributions. Just refer, specifically learned in detail this normal distribution maths, with the core examples, how it is working, how it is converting the values to a PDF form and then CDF form. It is very, very important. Make sense? So far, so good. So can we close this topic of naive Bayes maths, which was the very first discussion which you want me to do? And we can move ahead to the next discussion today, if you guys will agree with me. Okay, perfect. Second thing which I think you guys have asked, or the confusion, was Hamming distance. Okay, so when we were discussing about the K nearest neighbor algorithm, you must have seen the videos, right? K nearest neighbor, KNN. In those videos, I am talking about that this complete core idea of this algorithm is to check the distances of the k nearest points. For example, if the value of k is 3, so what we are looking is that if, let's say, some new data point came into picture, it is just checking it out. The nearest 3 points will try to find out the distance of all the points. And let's assume these are the 3 points which are nearest. It will try to find out the labels of that. For example, this point belongs to 1, this point belongs to 1 class, and let's say this point belongs to 0 class. So the probability of 1 is 2 by 3, and the probability of 0 is 1 by 3. So this new set of data point will say that I also belong to class 1. That is the core idea behind this k nearest neighbor, right? Now, in this specific algorithm, the distance part plays a very important role. And I must have discussed different kinds of distance metrics in this algorithm. I have talked about Euclidean distance. I have talked about Manhattan distance. I also have talked about Hamming distance. So when you are having a numeric data means when you will be having the points in a numerical form, then it is very easy for you to do the calculation, uh, whether it be Euclidean or Manhattan. If I'll ask you one question with respect to this part, because now you guys are saying that you have watched the videos and you know the difference between these two. By the way, this can also be asked from you. What is the difference, and which particular metric is better as comparable to another one? Or in other words, in the industry per se, when you are doing a project, what do you think, which particular metrics one should go ahead, and whatever be the answer you are saying, give me the reason behind that. I'm talking about Euclidean versus Manhattan, because you have watched the videos, right? You guys have said that you have completed. So you know the difference between these two. So if I'll ask you this question, what will be your answer? Any answers can I expect from anyone? Have you guys thought about this when you are learning this? Yeah.
In Euclidean distance, we calculate it by the diagonal basically. But in Manhattan, it is the absolute difference between the coordinates.
Yes, it's correct. That is the difference or the core difference between these two. Now, my question is, I'm going more in this maths part. In this
Um,
difference which you
the
have talked about, like in
Manhattan
real
and
time, which particular metric is better?
the Manhattan is the name of a city basically, in which there are the buildings are in a shape of blocks. So Manhattan distance is often used in grid-based system, basically navigation of Google Maps type of thing.
Okay. What about Euclidean? It's correct, yeah.
And
Just give me a moment so that I can listen your voice very clearly. And now, can anyone try to speak up?
Hi, ma'am.
Yeah. Mayank, you were saying something, right, regarding Euclidean. What is your say? What you are saying?
basically to calculate the shortest distance between 2 points. I don't have a good example for that.
Okay. Any other answer? Anyone? Apart from what Mayank has said?
In Euclidean, computations are less.
Okay. So, do you think in Manhattan computations are more as comparable to Euclidean? Is that so?
For
So,
Manhattan, computation will be less, ma'am.
exactly. In Manhattan, we are trying to find out the absolute difference, if you remember. And in Euclidean, we are trying to find out the square root of the square terms that we are getting, right? We are doing a square root. So basically, if let's say we will be having 2 points, uh, absolute. If let's say we will be having 2 points, one point is at the position x1 comma y1, and another point is having a position at x2 comma y2. So there is a point A, there is a point B. So if let's say if I'll ask you the Euclidean formula, the answer will be, it will be square root of y2 minus y1 whole square plus x2 minus x1 whole square. But if I'll ask you the formula for Manhattan, the formula could be the simple distance between y2 minus y1 plus x2 minus x1. I think, is this correct? What I have mentioned? Is
Yes,
this
ma'am.
fine? So the core idea is, let's say if you want to go from position A to position B. So Euclidean will try to give you this diagonal distance directly by applying this core formula. But Manhattan will try to see the difference between this path P1 and this path P2. And that's why you have two different values available and you are doing an addition of that. So I'm asking that which one is the better approach? So you will observe that by default in your documentation, if you guys have explored, Euclidean is the one which they have mentioned as a default parameter. Because in maximum instances, Euclidean works the best. And the default parameters which usually researchers feed in the algorithm is the one which works for almost all the kind of data sets. Uh, like almost 70 to 80% data will work perfectly well when they will apply Euclidean algorithm. It means somehow I mean to say that Euclidean is the more apt distance metrics as comparable to Manhattan. Why is that so? And at what point of time one should go for Manhattan? The answer would be Because in this specific case, you are trying to focus on the exact distance value which you want to measure, rather than going into the further xyz points and then doing the calculation for the individual points per se. In Manhattan, the beauty is that it's not a computationally expensive task. So if you want to save the resources, and if you know that there are too many points available, and I don't want my model to do the computationally heavy task, instead of that, because in KNN algorithm, distance is everything. If you will see, complete algorithm works in a way that distance is the focus point, distance is the hero. And if you want that your model will not do that much computationally heavier task, and you want the results as soon as possible, go for this Manhattan. You can change the metric and go for the Manhattan. That is the complete idea behind that. Anyhow, we were discussing about Hamming, right? This is being used whenever you will be having a string, or you can say string based data points that you have, string type data points that you have. For example, you are saying that I will be having two strings. One is Priya, another one is, let's say, Ria. There are 2 points, there are two values I will be having. One is Priya, another one is Ria. Or you can say Ritu. Okay? Now, in numeric forms, we can easily able to find out the distance values, right? It's very easy to do the computation. But how will we compare the points with respect to the string type data points available with us? For example, if you will ask me in real time, we do have in our data sets name of the people, we do have description of any product which you want to purchase in the data set. You have multiple entities which can be of string type. In that case, if you're applying a KNN based algorithm, so how will that be compared in terms of the distance values? Internally, Hamming distance is being used. It will basically try to see that how many entities are different from each other. For example, it will compare the, for example, okay, first of all, let's say this is a same string that we have, or different string also, that might be the case. Basically, it will just compare 0 1 2 3 4 0 1 2 3. How many strings values are similar to each other? And that is where, if there is a match, so if there is a match in the character, it will just do +1. And if there is no match in the characters, it will just say 0. And that is how, at the end of the day, whatever be the +1 values we are left with, it will give that number as it is. So if I'll just try to take some good picture of Hamming distance, if I will be able to get, then maybe I can showcase you. So this can happen in the binary numbers also. For example, here you can see, right? 1 0 1 1 1 1 1 0 1. So we are just comparing. For example, 0 1 and 1 0, there is a mismatch. So Hamming distance is 2. 0 1 0 1 0 1, there is a mismatch 3 times. Hamming distance is 3. So you can see, right? Binary numbers. I want to see the strings also. Let me just look into it. So you can see, right? I will be having A and B list available with me. So if, let's say, you will be having a character strings available in that list, geeks and geeks, 4 and 4, geeks and geeks. So let me just save this image again, and let me just copy that only, so that we will be able to get in a better idea what I want to convey here in both the terms. Numeric also, and but usually numeric people don't prefer to go with this because we have a better metrics available. Still, just for the understanding per se, I'm just showcasing you. For example, if you will be able to see in this picture, it's showcasing entirely things in a well better manner. We have a list, for example, 3 1 is a mismatch, so it will be +1. 2 2 is fine, 7 7 is fine, 4 3 is a mismatch, so +1 again. 9, 9 is a match, 5, 5 is a match, 8, 1 is again a difference. So there is a plus 1. 1 and 8, there is a plus 1. So it will be 4. Same thing you can go here as well. Geeks, geeks, there is a match. 4, 4, there is a match. Geeks, geeks, there is a match. Java and C++, mismatch is there. C plus and C mismatches there. Swift, Swift is fine. R is fine. Python, Python is fine. So at any point of time, this algorithm just says this as the core indication that if there is a match, just keep on adding the values. If there is no match, just take it as a zero entity. That's it. So via which, if there are string characters available in our data set, so because we cannot apply the Euclidean distance in that per se, one way via which we can apply is maybe we can do, there is a concept of word embedding where we are trying to convert every word into a vector form, and then we try to find out the difference between the vectors that we have. That's a different scenario altogether, which usually will happen in NLP based problems. There is a algorithm called as word to vec. There is an algorithm called as glov that is a part of word embeddings only. But here, by saying Hamming distance in the videos, I just want to indicate this stuff, that this is one of the metrics which might be used in the scenarios where we will be having a string type data. That's it. Now, if you have any doubts, please ask. What is the confusion in this point? Whosoever asked in the Hamming distance
So,
per
ma'am,
se, please
basically,
ask.
Hamming distance is only used in LLM and all that stuff, deep learning
It's
stuff,
only using
not in LLM basically, not in traditional machine learning, KNN. Is it?
मतलब ऐसा नहीं है कि it will not be used in KNN. As I told you that if let's say in the KNN algorithm in your data set, you will be having a data of let's say description. There is a column name by the name of description. ठीक है? You have multiple features, let's assume. There is a feature of age, there is a feature of maybe some continuous values. You can imagine anything, population, and multiple numbers are there. Thing is that, for example, you are working in any e-commerce based company and you are talking about the products, for example. So there will be a description of that product. There will be a product name of that. So there will be a features which are having a string type data available. The problem is if you will directly go with a default Euclidean distance measure, so with respect to this kind of features, that measure will not be applicable because it's a textual data, and our model will not able to do the calculation on this textual data. So in that specific scenarios, Hamming distance is the rescue point. If let's say you feel that this feature is really important for the prediction, if it's not important, then maybe you can just avoid using it, and whatever be the continuous numbers or numeric numbers that you have, you can go for Euclidean by default. But you are saying that no, this is important parameter, I want this point also to be included in my KNN. At that point of time, for this that specific feature, you can go with the Hamming distance. That's the core idea. Is that fine?
Yes. Got it.
Okay, perfect.
Priya,
Okay.
small
Yes,
doubt.
Vinny.
When we are actually applying KNN and suppose
Hmm.
the data set having the features, taking the
Hmm.
example you were discussing,
Hmm.
here we are having the string feature or
Hmm.
the non-numeric feature. We are also
Hmm.
passing to this passing this feature to our KNN algorithm. So by default for this feature it will take Hamming, and the others continuous feature it will be taking Euclidean distance. How
Yes.
actually
By
internally
default,
it's taking care of?
internally, yes, internally it will be taken care of. It will take for the string part Hamming, and for the continuous features Manhattan. Sorry, Euclidean. So if you want to change that, that is where you can apply hyperparameter tuning, but that is only for the numeric part per se. Here it is Hamming only.
And at last they will do the summation of both the distance for the
Correct,
final
correct,
distance calculation.
correct, correct,
Okay,
correct.
okay,
Okay.
okay.
Same thing we will discuss in our upcoming sessions where we will talk about uh, k-means clustering algorithm. In very soon we will talk. I think in this week only we had a talk about this. People usually in the interviewers might confused you by these two names, because people usually talk these two terms interchangeably. Please don't do that mistake. I'm noting that point to you guys, so that you will just have a asterisk symbol or note for this point. K-nearest neighbor discussion that we have done is a part of a supervised learning. Always, I think you will make sure this thing, right? Because whatever data, if you will see the implementation per se we have worked upon, it's a part of a supervised where the target is available. This K-means, which we will do in the upcoming sessions, it's a part of a unsupervised machine learning technique. But the core idea internally is somehow same. They were also using a distance metric of this Euclidean, Manhattan, and Hamming only. So we will do the discussion of this distance metrics, same discussion in the k-means also. But if in future you will get these two terms, they are not same. I'm just pointing it out. They are separate algorithms working for different kinds of problems in machine learning. One is designed for a supervised learning, another one is designed for unsupervised machine learning. So in an interview from this KNN, you can also get this question, that what is the difference between KNN versus k-means, because it's not interchangeably used, but people usually use that. Another question which is very important in terms of KNN is that in the industry per se, in the industry, you will always observe that people are not using KNN algorithm quite frequently. They are using KNN to do the data imputation. Data imputation. For example, till so far in EDA, we have done the imputation via mean, median, or mode, depending upon what kind of distribution our data holds. But now, if let's say you will be having a set of data points, you can do a data imputation via this KNN algorithm itself. So let's take that as a task of today's session, which I want you guys to explore. You need to write a code to do the imputation via KNN, because now you know via those videos that how can we do the implementation of KNN, right? Again, this algorithm is being used for both the kind of problems, whether it's a regression problem or it's a classification problem. I think you all know this point, right? So what I'm saying is, if let's say you want to do the imputation in a regression based task, for example, if the values are continuous, and I want to predict that what is the missing point it holds. For example, let's say you will be having a data. Maybe you can take a diabetic data itself in the task, because we have worked there. And if you remember, in the diabetic data, there was one feature by the name of insulin. And there were lot many outliers available in that. I remember that point. So there were lot of zeros were there. We have done the imputation of those zeros in our EDA task per se, if you remember, via the median, because we have seen that that data was highly right skewed as far as I remember. And because the data is skewed, it means it contains lot many outliers. So in that case, we know as per the stats that median is more robust to outliers as comparable to mean. And that's why we have done the imputation via median itself. Now, what you're supposed to do at your end today after this discussion, you need to apply, rather than median, just on this insulin data, insulin feature point, apply KNN algorithm and give me the predictions. What that is giving to us, that instead of zeros, what are the exact points which I would use? And this particular task will really be helpful for you when you go to the industry projects. Believe me, multiple number of times in the industry, when you will do the real-time projects, people are doing the imputation either via mean, median, mode, which we already have done the implementation, or via the KNN. So second way, today you have to do this task, okay? And in the upcoming session, definitely we will discuss this part, because it's very important to discuss. If I'll forget, please do remind me that, yeah, this is what we have to discuss, and we have done this particular part. Could you please let us know, is it correct or not, right? If I forget this point. Another thing which I want to talk about in the KNN, which I was just discussing, apart from this, in the industry, KNN algorithm is not being used in the data modeling. It is used for the imputation, but it is not being used in the data modeling. Why is that so? What is the reason behind that? Any answer? This is one of the very widely asked interview question. If you will say to the interviewer that you are using in your project, if you're working in a company and you are saying that I'm using KNN, they will definitely question mark you that whether you are using it in the deployment phase. Is that true? They will highlight this point. So why is that so?
Priya, because we can say that we know that KNN algorithm is a lazy learner, and
Yes.
we can justify that in actually in KNN algorithm.
Hmm.
KNN algorithm is actually not learning the data, actually not mapping the relationship between the input and output variable during the
Correct.
training phase. It actually doing everything at the, or we call that the new data point or the testing phase itself from the scratch.
Very much apt
because
answer. So you have to give
because
this
of
kind of answer
this,
to the interviewer. Yep.
yes, it will be not very convenient and computationally feasible to perform this KNN algorithm each and every time during the prediction.
Very
Yes.
much apt. Very much apt. Nothing I think I need to add on this point. What Vineet has said is very much apt. See what is happening. You must have seen now multiple algorithms. I think we are in a I think week fifth, and we have done so many algorithms till so far, right? And in every algorithm, we are doing some generalization. Let's start our journey with the linear regression. If you remember, we have tried to generalize a line of y is equals to mx plus c. Our whole training, uh, if you will remember that part, uh, was done in a way in the modeling part to get the optimal values or the coefficients of m and c. Do you remember? So we are using that optimizer of gradient descent, and that optimizer is really helping us to give that value of to get that value of m and c. But this is not something which is happening in KNN algorithm. If we have some coefficients, and at the time of prediction our model directly picked up that coefficients and give us the predictions, that is something which is a very fast process, because whatever time it has to take, it has already been taken in the training part per se, and now in the prediction it will just pick up the optimal coefficients and give us the new prediction. That's so easy step, right? But when we're talking about this KNN algorithm, there was no as such generalization which that model is doing in the training phase itself. That is the main reason why it is also called as a lazy learner. So at the time of testing itself, it is doing all the core calculations of finding out the nearest distances and then getting the probability of what is the highest number of points we are getting, and then or maybe finding out the average if it is a regression based problem, and then giving us the prediction. So what is happening is, when I'm talking about industry projects, definitely chances are very high that you will be dealing with a huge amount of data, right? If it's a small data, then also it is fine. We can go ahead with a KNN. But if it's a huge amount of data, which is very high chances if you're working with the industry level project, uh, and if it is not even huge, might be the data is a streamlined data, means on a daily basis, the records will keep on adding. So that is again a bigger issue, right? So in that specific scenarios, we cannot go ahead with KNN because no one has that much patience to wait for a long time to get the predictions done. And that is why I'm saying that it is the only advantage of this KNN algorithm, majorly in the industry per se, is to do the data imputation. Why is that so? Because in the data imputation itself, we have a static data, fixed set of data points are there. And we have a time also, because we are doing a EDA part. It's a part of a EDA, right? It's not a part of a modeling. We are not doing any predictions here. We are not doing anything. We're just doing a imputation. In that case, it is good to go. But in the predictions per se, it is very bad to go. So data modeling per se, in the industry part, you will not go ahead with the KNN multiple number of times because of this reason that KNN is a lazy learner. Internal intuition, I think we need already have shared, and I have also shared the points uh, about that. Is it fine? Is it okay for everyone, whatever things I'm saying here? Will you be able to answer
Yes.
this question if someone will ask you? Okay. Please do this as a important thing. You have to do it in the upcoming session. Definitely, I will take a look on this part also. There was one more point in my head, but I'm just recalling. It's not coming up now. Okay, let's go ahead. If it will come, I'll share with you. But anyhow, this is the core part. Yeah, it came. One thing which I want to say here is in this KNN, if you remember, we had a discussion of SMOT. Do you remember? So,
Yes.
in the industry per se, it's a part of a oversampling technique. If you remember, in the data imbalancing part, we have seen this, right? It's a part of a oversampling. What is the meaning of that? Let's say if you will be having a data point 0 belongs to 500 data points, and one is label which is having almost 200 data points available. So what oversampling usually does is it will try to reach this number to 500. Now I told you there is one random oversampler. Random oversampling means it will try to replicate the 200 data points that we have to 500. That is something random sampling it is doing. But in the SMOT part, it is internally using this KNN algorithm only. So the second task of today's session is to go through the, I will share you one article also that how the SMOT working will be done. You have to read that article and come up with a complete idea that how the SMOT works. I will listen from you. Because now you have an intuition of the how the KNN algorithm will work. And the major reason why, again, this is not being used in the production part per se, in order to handle the data imbalancing part, is the same, which we have discussed. Because internally it is being used as a KNN algorithm, and KNN algorithm is a lazy learner. That is the idea of this mode technique. But that is not a question which I'm asking from you. What I'm asking from you as a second task of today's session is that how the internal working, because now you are already know the internal working of KNN. So how in this mode technique, it will be able to find out the nearest samples and will provide me that oversampling thing to be done, means reaching from 200 to 500, creating a new data samples via the KNN. It's a very, if you will see the internal intuition behind SMOT, it's very interesting. So please do your own research. I don't want to spoon feed here everything. I don't want to teach you here. I want, first of all, you will learn on your own, come up with few points, and then I'll try to add few more points on top of that, just like the way we have done today, right? You have already seen the videos, learn it from there, and then you had some doubts. I clarified everything today. So similarly, two tasks you have to do. One is data imputation. How can we do via KNN? You can take a help and reference from Google. I don't have any issue. The important objective from my part per se is that you will be able to explain to me in a way that a layman person will also able to understand. That is something which I want from you guys. Second task is how will you explain to anyone how the SMOT technique works, right? The internal intuition behind that. That is the second task which you have to do in today's session. Make sense? So far, so good. Done? Perfect.
Priya,
Now, yes,
one
please.
small doubt,
Hmm.
not related to this KNN,
Hmm.
just related to the tree-based model. Priya, we know
Okay.
that tree-based model, whatsoever we have studied, starting from decision tree to random forest, they are all non-parametric model. So in non-parametric model, do we have any sort of cost function associated?
No, there was no as such cost function. If you're saying cost function in a decision to a random forest, that cost function is nothing but, in other words, Gini, entropy, information gain. because that is what we want to optimize in the tree-based data structures. So what you are saying as a cost function is this only in the tree-specific data structures. Because our core idea is to minimize that Gini value. For example, in linear regression, we have a cost function of MSE, mean squared error. The core idea was to minimize that MSE. That's why we are creating the optimizers and coming to a point where we will be having a minimum value of M and C. So that was the cost function there. When we went to logistic, cost function changed to sigmoid. We have a 1 upon 1 plus e to the power of minus z, right? Which was the z value is the straight line, mx plus c only. When we went to the tree-specific data structures, that cost function changed to that Gini value or entropy value, means a measure of impurity. And the final target part is to create a structure, to create a tree in which at the end of the day, we will be having a minimum impurity or maximum information gain. So minimum impurity, one parameter, and maximum information gain. That is the cost value linked with the decision tree classifier. In decision tree regressor, if you will ask me, that cost function will get changed to again MSE, mean squared error. Decision tree regressor was there, decision tree classifier was there, or random forest classifier was there, random forest regressor was there. So accordingly, the parameters of will get changed, that cost function will get changed, but the maths behind that will remain the same. Is it fine, Vineet? Is that your question?
Yes.
Okay, perfect. Shall we proceed now? Everyone is comfortable till so far, whatever things we have covered up? Regarding these points, again, I am saying, if you will ask me, Priya, what is the good reference apart from whatever you have taught us regarding the tree-specific data structures which I am talking about, refer the standard book. You will get an amazing, intuition behind these algorithms. Whatever I am, because it might be the case that I want to convey you few things, but you might not be able to get in an appropriate manner, or you might get misunderstood few things also. It might happen, right? So the better idea could be that you will refer one book apart from what I am teaching here, and at any point of time, if you will feel that something is not clear, or something you have learned different in the live sessions, and there is something different is written in the standard book, you can just reach out to me that, Priya, this is something where I'm facing some trouble. Could you please help me to understand this point? Definitely I'll look into that point and will help you out. Okay, but please refer, apart from what learnings you are gaining from these live sessions, any standard book. And specifically for this tree specific data structures, it's one of the most important topic in the complete machine learning course which we are discussing in these videos. One is this random forest is very important. Another one is we will discuss about boosting algorithms, another interesting and important topic. Maximum number of times in the companies, still today also, if you will ask to the people who are working in the companies that what is the algorithm which you are using very frequently, either they will say random forest or they will say XGBoost. Maximum number of times in maximum companies, already a pipeline of these two algorithms is being created, and whatever the data is coming up, they are doing a EDA and applying these algorithms on top of that and getting the results. Even sometimes it's not a good idea, but sometimes what is happening in lot many industries that they are not even comparing with the other algorithms, that how the performance is being there. But that's the reality in maximum industries. But again, it depends on what kind of data you're working with. But whatever, because I have a good network of people and I used to connect with them and ask from them that what kind of algorithms are you using uh, in whatever domains. I have a network with the friends, so I used to ask from them, and 99% of times, I don't know now if might be the case my data is biased towards those people. Again, biasness might be there, but I have seen that people said this to me only. And even when I was working in the company, in that startup, and prior to that also, I was also using the same algorithm. So that is the clear cut idea that this is something which is important. And when I was giving the interviews, so I had given the interview after finishing my masters in IIT Hyderabad to the Google as a data scientist position. In that interview, in the very last round, I won't be able to clarify. So what was the question they have asked to me is bit complex. I'll talk about that also when we complete that algorithm in the clustering part per se. But what I'm saying here is that in the algorithmic part also, maximum chances are there that in the interviews from Google to the startup based company, they will ask you the questions with respect to the tree specific portion. And when I'm talking about tree specific portion, they will ask you the data structure in depth part also. They will ask you regarding the core data structure of tree. So if you're not aware about that, please study that part also. Right, if you want, I can upload few videos of mine with respect to tree data structure. I will have to look into it, but definitely I can create one, or if I have already, I will try to upload it in your dashboard. I'll not discuss in the live sessions per se this data structure in depth part, but maybe I can share you the videos in the dashboard, and in your own time, whenever time permits to you, please refer that video and try to learn it. Or there are other resources also available on YouTube. If you want, you can learn it from there. That is not an issue. The important thing is, please make sure you will learn that thing. Okay, make sense? Now the next discussion we will do for a few more minutes, don't worry, 30-40 minutes we will do the mathematical aspect discussion of another algorithm, which is SVM. The full form is support vector machine. Again, very interesting algorithm. You can say it's algorithm on top of what we have learned in logistic regression. It's an extension of that. If you remember when we were discussing about linear regression and logistic regression, I don't remember the name of that guy. He has asked to me that, Priya, whatever talk you are doing here with respect to these algorithms, you are assuming that the data is in a linear fashion. What if our data is not in a linear form, right? And then at that point of time, I told him that, please wait for a while. We will come up with one interesting algorithm which will be efficiently able to handle that kind of a problem. And today, let's deep dive into that algorithm, which is support vector machine. Again, a very widely used algorithm in the industries per se. Wherever you will see that your data, whatever domain you're working with, is a non-linear specific data, because this algorithm handles, although it also handles linear specific data also. I'm not saying that it will only handle no linear only, but what I'm saying is linear ke liye to we have other options also, but non-linear ke liye we don't have any other alternative. And that is the beauty behind this algorithm. That is where this algorithm gets a lot of fame. Otherwise no one will use this algorithm, right? So whenever you are like ki, in my data linear data is also there, and non-linear is also there. It's a combination of linear plus non-linear. So definitely you cannot go with logistic regression. You can only have that SVM is in your picture, is in your head. You can go ahead with that. Okay? So non-linear data, it will be able to handle very much aptly. Second beauty about this algorithm is it is more robust to outliers. So if let's say you will be having a lot many outliers in your data, and you have handled it, but still you will be like, ki, I won't be able to handle 100% of my records, and even I cannot remove them because it will be a loss of information. So which particular algorithm should I go with? SVM is a great choice at that point of time. So if your data contains lot many outliers, and somehow you have handled few of them, but still there are many outliers available, go with the SVM. It will be able to handle it very efficiently. Internally, the kind of maths it is using, uh, it's very superb, right? We will discuss about that. Again, this algorithm is really helpful for both the kind of problems, classification as well as regression. So this is the, you can say, advantages of using the, or you can say not advantages, I would say properties of SVM algorithm. Non-linear data handled quite efficiently, robust to outliers, useful for both the classification and regression kind of a task. Now, as I told you, you will observe it's an extension of logistic. So let's try to understand logistic or linear, both of them you can say. If I'm saying classification, there is an algorithm name by the name of SVC, support vector classifier. So you can refer the documentations to understand that part in a more appropriate manner. Today we will just take a gist of this, and in the upcoming session we'll try to finish this. In the regression part, we will be having SVR, called as support vector regressor, used to handle the problem of regression specific task. Okay. Now, how does that work? What's the internal intuition behind that? Let's try to deep dive into that fact. See, when you will be having a linear specific data, let's say that height and weight example which we have done, or let's assume if it's a classification problem, we want to classify between two classes. So let's assume we will be having one set of data points available here and one set of data points available here. Anyhow, in the logistic also, we are trying to find out the best fit line only, which will be able to classify these two data points in an appropriate manner. And there can be multiple ways to create these classes, right? Lines, sorry, not classes. Now, if I'll ask you that which one is the more appropriate or the best fit line, let's assume this is the line L1, this is the line L2. If I'll ask you that out of these two lines, which one is the line which will more appropriately classify these two set of records, maybe the class A that we have and the class B that we have. So what will be your answer? Use some maths behind this with respect to whatever knowledge we have gained in our previous sessions.
I think it will be L1.
Okay. Any other answer?
I guess L2.
Okay. So someone said L1, someone said L2. Can you guys give me the reason behind your points? Who said L1?
I have said L2, and I guess we can calculate the distance between the point from
Okay.
L2.
Then
Let's
assume.
See.
Uh-huh. Okay.
Then
Go
we
ahead.
can see which are the points which goes after L2 and which are the points which comes under L1, L2 basically.
For example, let's say we computed the distance which you are saying. And I'm saying L2 is having more distance with respect to this data point also and with respect to this data point also, as it is visible from this figure also. So in that case, what will be your answer? L2 or L1? L1 is having low distance in this point, but higher distance in this point. So which one is a better line?
I guess L2.
It should be L2. It should not be L1. Why? What we want is, we want the line to be in such a way that it will be far from both of the points. It should not be inclined towards any one of the proportion. Then it will be a biasness problem. In L1, the line is more inclined towards this orange data points. And it's very far from this yellow data points. We want a line in a classification task where the lowest point, for example, in this case, let's assume this is the lowest point that we have. It should be far from that line, and lowest point, let's say this is the lowest point, it should also be far from that point. Almost In an ideal case, 50% 50% ratio will be there. Means the distance value d in both the cases should almost be similar. And
There
that
was
is
one more.
the best line which you can say, because that will do a better classification of data points. Will you guys agree with me on this note?
Yes.
Why I'm saying L2 is better than L1 as per this
There
image?
was one more point that I forgot, that
Yeah.
when we will be having spacing between both the points basically in L2 basically, and if we
Hmm.
have new data, uh, so we can easily L2 will
Correct.
be better than L1 basically
Correct.
in
That
that
is the
case.
core idea. If we will be having a new set of data points which will come, and it will see that which one is the class it belongs to, whether it's A or it's B. So, broader the difference, like higher the value of this D, better will be the classification. There will be less ambiguity, less confusion. So, for new set of data points, higher this d value which I'm talking about, I hope this is clear what is d I'm talking about here. You will be able to see that there will be a better classification among the given set of classes A and B. Is it everyone agrees with me on this note? It's very crucial point, very important point mathematically. If you will just think about this part which I'm talking about, it will or it should make sense to you. Now, the important objective or important focus which I'm saying here is to uh, maximize this gap. That's what I'm saying. Higher the gap between the lower point in any class and this new line, the best fit line, better is the clarity, and you will be able to generate a good model where the proper classification will be done. That is where the core idea behind this logistic regression also came into picture. There also we're trying to create a best fit line only. It's just that after creating that line, we are trying to apply a sigmoid function on top of that, because we are looking forward towards the probability of a data point belonging to a class A or class B. That's the core idea. We have done the entire maths also in that particular algorithm, right? Now, if this is about a 2D plane, and when we're talking about two-dimensional data, it's very easy to visualize. Now, in today's discussion or in the upcoming discussion, for few people it might be confusing. I'm really sorry for that, but you should be bit good in terms of creativity, because when we're talking about SVM or like SVC or SVR, these algorithms, you have or we will consider a bit higher plane, 3D, 4D, 5D, 6D, and 7D. And definitely I cannot picturize that things with you just like the way I usually do in these particular topics. I cannot plot anything. We have to visualize it. I'll try my level best to communicate you very efficiently the way which I want to efficiently communicate. But still might be there will be a confusion. Maybe you can ask me multiple number of times that what I want to explain on this note, and then only I think we will be able to have a better understanding. And one more important thing, please don't leave this week's sessions. Try to connect with me in a live mode itself, because in a virtual mode or in a recorded mode, if you will watch the videos, you don't have an option to say to me that Priya, please explain this again, right? And these topics are bit tricky, as I told you, because we are working with a higher dimensional space, and might be the case that when I'm explaining for the first time, you won't be able to get anything. You'll be like, what she is talking about, and I don't know anything. But please sustain with me, please be patient, and if you will ask me 100 number of times also to repeat any point, maybe I'll try to take some pictures from Google, or we'll see some platforms. I also have explored today, also did some research that how can I explain you guys in a better manner. There are some platforms via which I can make the plots and showcase you. But the important point here is that if please, in the upcoming sessions also on Wednesday and Friday, we are meeting live. Try to join live only. Don't rely on the recorded videos. This is for those people who will watch these recordings today or tomorrow when the recordings will be there in the dashboard. So please make sure you will watch it in the upcoming session on a live mode itself, right? Here, if you will be able to observe, when we are working with a higher dimensional space, whether it's a 3D space, 4D space, 5D, or ND, what is happening is, in 2D, we called this as a line, right? We're talking about best fit line. In 3D, same thing, you will call it as a plane. Okay? And in higher dimensions, the same thing, you will call it as a hyperplane. You must know about these things, but those who are not aware, you can take a note. In 2-dimensional, we will be working with finding a appropriate line, right? Which is the best fit line, which will be able to classify our data points into 2 categories in an appropriate manner. In 3D, that same line is called as a plane in mathematics. And when we are working with a higher dimensional space, maybe 4D, 5D, 6D, 7D, ND, that same thing is called as a hyperplane. So SVM basically tries to find a best hyperplane. You must have seen this line in many website standard books also, that it usually tries to find a better hyperplane. So what is the core idea behind that? Let's try to understand. There is a very important concept in SVM called as kernel trick. And this is one of the important topic as per the interview perspectives also. See, whatever things I am sharing here for the interviews perspective, maybe you can bookmark it or you can make a separate questions or list of questions for all those topics, because all these questions I have experienced myself in the companies from Google, Microsoft to startups like you can say Blend 360, Paytm, and Uber. So I have given lot many interviews in multiple companies, right? So what I'm trying to convey here is that these questions have been asked from me as a data scientist position. So chances are very high that these questions might be asked from you as well. So kernel trick is one of the most important topic in SVM, and this is the hero of SVM, I would say. Why? Because what usually happens is that uh, again, there is a functions linked with every kernel which we are using. I will not go into that depth of maths inside that kernels which we have, but I'll try to showcase you the importance of these stuffs. Okay, I'll again fetch up one image. Then I think it will be very easy for you to understand it intuitively. What I mean to say here. Uh, this is the image. Also, there is one more image, which let me just fetch that up also. For those people who are not really sure what is the meaning of when I'm saying linear data, because I told you, right, in the starting of the discussion of SVM, that it usually handles in a great manner non-linear specific data. So what is the internal intuition behind that? When I'm saying any data is a linearly separable data, it means that we can create a line in two-dimensional space, which basically helps my data to classify into 2 categories. As you can see in this given picture, red and green, properly classification is being done. When I'm saying that any specific data is non-linearly separable, this is kind of this. So if you have this kind of a data set available, can you create any line here? Can you create any line? Can you create any line which classifies these 2 data points? It's not possible at all. So that is the literal meaning of when I'm saying non-linearly separable data points. And when you will be working with a real-time data, many number of times you can encounter when you will do the plots of your distributions of the data points that you have, this kind of data as well, which is non-linearly separable. So in this kind of data is what I'm saying that you cannot apply. If you will say that, Priya, I'll apply logistic regression for the classification per se, this is not feasible. This is big no. You cannot apply because The assumption of these algorithms is that your data should be linearly separable. Then only these algorithms will be helpful for you. And that is where I would say this SVM became the hero. And from the day this algorithm came, people will be really clearly able to handle in a very much efficient manner this kind of a data as well. Prior to that, that was a bigger issue. Ki, theek hai, if my data is linearly separable, then it is fine because it's very easy to handle. Then what they usually tries to done is that they usually apply some sort of a maths to convert. How can we convert a non-linearly separable data to a linearly separable one, which contains a lot of wastage of data points also. If you will go with the maths behind that, you will be able to understand it in an appropriate manner. But that is not something which is efficient way, and that is where the SVM algorithm came into picture. So what this algorithm says is that if, let's say, in a two-dimensional space, your data is non-linearly separable, right? This is what we have said, that our data in a 2D space is non-linearly separable. Now the question is, theek hai, logistic regression won't be able to handle. Just give me the idea that how this SVM is working, how this SVM became the hero of this particular part if logistic regression is not the one. Because of the concept of kernels. So what this kernel says, there are multiple different ways of kernel, and by default, if you will refer the documentation, there's something called as RBF, which is the default kernel which is being working. I'll talk about this in a later stage. But in a layman term, if I have to explain what is the kernel trick all about, it says that convert your low dimensional data into a higher dimensional space. So इन्होंने क्या किया? They have converted this 2D data to a 3D data. Now you can see it's very easy to convert to create a plane, and now you will be able to see the class A and class B is easily distinguishable. So क्या हो रहा है kernel trick में, that we will be having a lower dimensional data, and when we are looking that data into a two-dimensional space, that data looks non-linearly separable, means we cannot curate any line out of which we will be able to differentiate between the two data points that we have. So this kernel trick, what it tries to do, they apply some sort of mathematical function and converts lower dimensional data to a higher dimensional data. Now, what is the beauty about this? What will happen? When it will be converted to a higher dimensional space, by the way, this image shows 3D, it can be 4D, it can be 5D, it can be 6D, it can be 7D. Until or unless it will not create, or we will not have an appropriate hyperplane where we will be able to classify the two data points, this process will keep on going. But the core idea will be to curate a higher dimensional space where the hyperplane will be able to differentiate between the two data points. And that is how the classification is being done. That is how the actual problem of not able to handle that non-linear data points will be resolved in this specific case. Is that point is clear? Very, very important point in the complete discussion of this kernel SVM. So that is why if you will be able to see in multiple standard books, they will say that SVM majorly tries to find the best hyperplane. So why hyperplane? Because here we are having a higher dimensional space, although our data is in a lower dimensional space itself, if you will plot it. But to classify it in a proper manner, kernel will help the data to convert to a higher dimensional space so that data will be able to classify appropriately by building a hyperplane altogether. Yes, till so far everything is clear to everyone. Shall we proceed now with the maths of hyperplane? So the next discussion will be that what is the mathematics behind this hyperplane? We understood what is the meaning of hyperplane, but what is the maths behind that? How will it be able to find out the optimal decision boundary, I would say? For example, this is something which we will call it as a decision boundary, right? By which our two classes will be appropriately classified. It is making. What is the maths behind that? It might be sounding bit tough, but if you will just be there with me, it will be, I'll try to make it as much easier as I can with the discussions. But till so far, everything is fine. whatever we have discussed? Any doubts still so far? Anyone?
Priya,
Yes.
I got the point you explained, but
Mhm.
I'm not getting what is actually this kernel is.
Okay.
एक्चुअली है क्या ये, क्या फंक्शन है या क्या है, मतलब लोअर
ठीक है.
डायमेंशन से हायर डायमेंशन को डेटा को मैप कर रहा है?
Okay, let's talk about this kernel in a lot more detail. So, one thing which you will see, even if you will apply, either you will refer the documentation of SVC or SVR, there is one parameter which you will see is a kernel, which is RBF. Now, if you will go in the depthness of this kernel part, which I'm talking about here, there are multiple kernels in maths that we have. One is linear, one is poly, one is RBF, one is sigmoid, one is pre-computed. If you are talking about sigmoid, it's nothing but is a logistic regression algorithm it will be able to form. Now, what is this kernel is saying? Sigmoid kya tha? Sigmoid is a function, right? Sigmoid was a function which is 1 upon 1 plus e to the power of minus of x or minus of y. And
Hmm.
instead of y, we have placed that equation mx plus c because we want that equation of a line to do that probability wala part. Similarly, all these also are the functions: poly, RBF, pre-computed, and linear. Now, depending upon which particular kind of dimension you want to convert your data, different functions are there, you can say. For example, if let's say you are saying that I want to convert my data into a three-dimensional space, right? Then poly or RBF is the one which works well. RBF works well for a non-linear data. If you will go to the Wikipedia and search about this RBF kernel, you will be able to see a complete maths behind that. That's the best resource which you can refer. Even I used to refer this only documentation for the understanding of this RBF. Radial basis function is the full form of this RBF. If you will go inside this, you will be able to see the popular kernel function used in the machine learning algorithms. In particular, it is commonly used in support vector machine classification task. This is nothing but is a function, and this function is nothing but exponential negative of xi minus x bar, which is the mean value divided by the 2 sigma square whole square. So just like the way we have sigmoid function, we have this radial basis function also. What it usually does, it usually tries to convert your data, non-linear data, which is in a 2D space, to a 3D space by default. कुछ तो फंक्शन चाहिए ना, सो कन्वर्ट करने के लिए हाउ विल माय मॉडल विल बी एबल टू कन्वर्ट अ लोअर डायमेंशनल डेटा टू अ हायर डायमेंशनल स्पेस. So that is something which we are saying is a RBF kernel that we have. If let's say you're working with a linearly separable data, you know that my data points are linearly separable, but still you want to convert that linearly separable data also to a higher dimensional space, maybe 3D, 4D, 5D, 7D, and so on. In that case, your kernel will get changed to a your function. When I'm saying kernel, internal intuition is function will get changed to linear. कि डेटा हमारा क्या है, लीनियर फॉर्म में. नॉन लीनियर फॉर्म में होगा तो इट्स आरबीएफ. Poly means if you want to convert into 4D, 5D, matlab more than 2 is a part of a poly. Sigmoid, as I told you, it's we all know, we have a great discussion about this. So you can see, specifies the kernel type to be used in the algorithm. If none is given, RBF will be used. Degree is something which is the dimensional space which you want to convert. By default, you can see in our discussions, in our algorithm, it is 3. Means by default, it will try to convert your data from 2-dimensional space to 3-dimensional space. But again, we can do a hyperparameter tuning on this kernel wala part also and on this degree wala part also, which basically helps us to understand that what is the best dimension for my data in which hyperplane will be appropriately done and the proper classification will be happening. So if you're asking what is this kernel, this is nothing, in a layman term if I'll have to explain, is a function only which basically helps my model to convert this low dimensional data to a higher dimensional data. So whatever be the input values you have in a 2D space, you will feed that input values into some function which is f of x, whatever be the function you're applying, and it will automatically convert that data into a 3D space, and then it will try to fit that. When you're saying svc dot fit on the training set, it will try to create a hyperplane on top of that. Is that answers your question, Vineet?
Yes, I got the internal intuition, but yeah, when
How
we
will
will
it
do the
convert? How will it convert? This is the function which it will use: exponential minus of x minus x bar divided by 2 sigma square. There is a lot more maths behind this. You can see, right? There is a Fourier random features. There is something called as, in a maths we have an idea of Fourier transformations which is being used internally. But as of now, for today per se, just consider that there is a function which is linked, and we are just passing that function to our model to say that please convert my data from this 2D space to the 3D space by applying a function of RBF, or by applying a function of sigmoid, or by applying a function of poly, or by applying a function of linear. So depending upon what kind of data you are dealing with and what kind of degree you want to curate, it will directly use that thing only. So degree is nothing but what kind of dimensional space you want to go. By default, degree is 3, and kernel function which is being used internally is this RBF. You guys don't need to remember the exact functions. For example, same thing which I have talked a few minutes back, you don't need to remember the distributions of PMF and PDF. Ki what is the PMF for all the continuous random variables, and what is the PDF for all the discrete random variables. Similarly, what is the kernel values, exact functions, exponential values of uh, all the kernels that we have. Don't need to remember. No one will directly ask you that can you give me the exact formulation of that, because there are multiple things which we have to learn. The core idea is the logic which you have to understand, that okay, how is this conversion is happening, what kind of maths they are using, because model apne aap to karega nahi. We need to provide any kind of function so that it will map that. It's kind of a mapping. What functions usually do in maths, it will try to do a mapping only, right? So we need to map those same data points into 3 dimensions or 4 dimensions or 5 dimensions. So how that will be mapping will be done, that is why this kernels only. So here you can see we have x-axis, y-axis, and the z-axis. So this is the visualization of 3D. But when we go to the 4D, 5D, I think it would be hard to find the pictures also. But let's see how will we do that. But anyhow, till so far things are clear. Now, in the next part of discussion, we need to see the maths behind the hyperplanes. And when we deep dive into the hyperplanes maths, then I think things will be much more easier and intuitive to understand that how is this decision boundary is being done. Before moving towards that equation of hyperplane and the maths behind that, let's try to understand few terms. And I think the mathematical part of hyperplane we will discuss in the upcoming session, because it's again maths heavy, and we already have 2.5 hours of sessions done. So no, I don't think you guys have or me have that much energy which we have in the starting part of the video. So let's try to just wrap up within few minutes this session with few important points regarding support vector machine. So what is usually happening, let's assume that we will be having 2 classes available, right? One is this specific class. Now you can assume that here I'm talking about a high dimensional space only, okay? Because I cannot create the picture of that, but you can assume, because we are talking about hyperplanes here. Let's assume there is a second class which is available here in the hyperplane. So there are few terms which you will observe. The algorithm says support vector, right? Support vector machine. So what is the meaning of support vector, from where this name is being originated? The points which are very near, like almost the distance is 0. So what usually happens to create a decision boundary or to curate a best hyperplane in the SVM algorithm, first of all, it will try to curate 2 specific lines for both the classes. One, you will observe that both the lines are very near to the below point, almost the distance is 0 or very, very less. This is, you can consider it as a positive class. This is considered as a negative class. And after once this lines will be created, again, between line will be having this equal distance, and just in the middle, one more line will be created, which is called as a hyperplane or the decision boundary. How it will be created, that maths we will discuss, but or what is the equation of that hyperplane, that we will discuss. But this is the intuition. This is called as decision boundary. And these points via this line or this line, this is called as support vectors in SVM. Support vectors. So what is the meaning of support vectors? The closest point via which that pi plus line and pi negative line will be formed is called as a support vector, which is having almost distance value is approximately equals to 0, or it will be very, very less. It's very, very less. So first of all, internally, this algorithm will try to find this these two lines, and then we have one plus line, one negative line. This particular gap is something which we called as a margin in maths. So what we want is whatever be the in between line out of these two points that we have is called as a hyperplane or the decision boundary, which will basically able to efficiently classify the two data points. The ultimate target is to maximize this margin, is to maximize this complete value of d dash, right? This margin value, margin is the gap between the below line and the upper line, and the complete target is to able to have that kind of a line where the distance will be maximum. Higher the distance, higher the margin, better is the classification being done. We already have discussed this in a 2D plane also, right? Higher the distance, higher the gap between the two classes. When a new set of data point will come, there will be less ambiguity because the margin is very, very high. So this is support vectors. So these 2 points are the support vectors. There can be more than 2 points also, but the simple thing which I want to communicate here is via which the below line and the above line is responsible, our model is making. This is what we call as a support vectors in SVM. This is important, this much important, the name is also being given via this specific naming. Now, what is the equation of a hyperplane? For example, if I'll ask you, what is the equation of a line? What is the answer? What is the equation of a line?
Mx plus c.
Y is equals to mx plus c. Now, with this equation of line, in the upcoming session, we will try to intuitively find the equation of a hyperplane. ठीक है? अभी नहीं करते. Let's do it in the upcoming session. That
Ma'am,
how, with the help of this, we can generalize the equation of a hyperplane. We will use this equation only, and step by step, we will do some derivations, some mathematical part, and then we will get the equation of a hyperplane, which is being used in this specific decision boundary to form the hyperplane, or in this specific decision boundary to form the hyperplane in higher dimensions. So this is the next important point which we have to do. And once we will be able to get the idea behind that maths, then we will deep dive into the implementation of this algorithm, how it works internally, what is the code work behind that. And I think in the upcoming session, I'll try to target to finish that 2 points in the SVM, and with that, the algorithm will be over, and then we will move towards the further algorithms in machine learning. Yes, now if you have any doubts, I'm open to take, and then we will wrap up. If anyone wants to leave the session, they can leave. We will not cover up anything beyond that.
Yeah,
Thank you so much for joining in. Yeah.
So for the hyperplane equation, will it be similar to the equation which we study in 3D geometry, like ax plus by
Yes.
plus cz equal to d?
Very good. Correct. This is where we will start our journey. Ax plus by plus
plus
c
cz.
equals to 0. So this is the generalized equation of, you can say, y is equals to mx plus c in a general form. I hope in the maths you can you have learned it, that this y equals to mx plus c can be written like this. And from here only, the equation which you have learned in your maths 3D and 4D equation, this is same only. This is what I'll showcase you in the upcoming sessions. You are saying it very much aptly. Correct. Any other doubt? Anyone? So far, so good. Discussion about naive bias, KNN. Two tasks I have given. First is how can we do the data imputation. If you have done maybe today night or tomorrow itself, you can share with me via Telegram itself. I will look into it. I have seen one guy also has shared. Pran joined. I think he left the session in between. Might be some internet issue, but I'll look into his code also and will give the feedback. If anyone has done by tomorrow itself, please share with me. If I'll have the time, I'll look into your code and give you the feedback. So one task is to do the imputation via KNN. Second task is to read an article about the smooth technique, how it works. You can refer the ChatGPT platform also. The intuition behind that, it will showcase you. And let's see who will be able to come up with the great results out of these two tasks.